Good afternoon, actually late morning, early afternoon. I'll be presenting on the SPS deck system. It's for truss rehabs. You might ask yourself, what is SPS? Well, that is one thing I'm going to answer. What's its history? Where did it came from? Why is it here? Where in the world has it been used? It's been used extensively. And how are we going to use it here in Texas? First of all, sandwich plate system. It's a sandwich. It's two steel plates with a polyurethane core. Now, the polyurethane core is basically just to keep the two plates separate. It's a pseudo I shape, if you will, which acts like an I shape in flexure. It's hermetically sealed, so the core is never exposed to the environment as soon as it's injected between the plates. There's some common thicknesses for bridges, anywhere from 1 3/4 inches to 2 inches, and usually the weights for an 8-inch thick concrete deck is about 100 psi, and SPS, a 2-inch, is about 45 psi, which is basically over half the weight. As you can see, it's been used extensively pretty much all over the world: Europe, Canada, US, and Asia. Recently, Asia. It started off as a naval. What they did was, when the hull or the deck of a ship would get damaged to the point where, hey, we need to fix this or we need to replace it, they would come back, lay a new sheet of steel over top of it with spacers, and then they would inject the polyurethane into it, which would cut down on the weight and they don't have to cut out the old deck. They use it in stadiums. Basically the platforms that the bleachers sit on. It's lightweight. It works good. It's strong. Flooring systems in buildings, and pretty impressive barriers. I mean, that truck's not going anywhere after it. Now, bridges, what we're interested in. New construction. This was actually Martin Branch over or Center Creek, however you want to call it. Basically, it was prefabricated, brought on site, and assembled, and then placed. That's almost the finished product, but as you can see, pretty lightweight. Didn't need a big crane. Set it and go. It was pretty quick. What we're really interested in is redecking of truss structures. This is Dawson Bridge in Edmonton, Canada. This is used extensively in Canada on their trusses. This is the finished. Those are connection plates, if you will, to connect the plates to each other. In this case, they use the asphalt as their riding surface, finished riding surface. This is probably the first bridge in Texas. Yes, Tom. I see you smiling. This is HS 174 over the Brazos River. It's actually over the headwaters of Lake Whitney. It's a 3-span continuous deck truss built in 1950. It's functionally obsolete and structurally deficient. Why is it functionally obsolete? Well, it's only a 26-foot roadway. Doesn't meet FHWA standards right now, which is 2 lanes, 2 12-foot lanes, and 2 1-foot shoulders. It is structurally obsolete due to the corbel there, which supports the approach spans. And the current deck is 6 3/4 inches or 6 1/4 inches. Well, to make it not functionally obsolete, we have to increase the roadway to 28 feet. And we also, per standards right now, 8-inch deck. Well, the 8-inch deck created a lot of issues with the gusset plates. Almost every single gusset plate would need additional supplementary gusset plates, and almost every gusset plate would have to have the rivets replaced with high-strength bolts. Well, If we reduce the deck dead load by 50%, what happens? Well, now we eliminate the need to totally do any kind of supplemental gusset plates, and we substantially decrease the amount of rivets that need to be replaced with high-strength bolts. And here's basically a typical cross-section. This is going to be a phased project. We're actually going to, that'll actually be the crown point, as well as a connection between phase 1 and phase 2. And as you can see, there's the center line of road, and there's a 1 foot difference. We can do that. And that was actually ended up being cheaper. Originally, we wanted the crown point right there at the center line, but they go, no, we can do it cheaper this way. And we said, okay, we can accommodate that. As you can see, it's actually quicker too. 2-inch SPS deck, 1.9 man-hours per square foot, compared to an 8-inch deck, which would take 3.9 man-hours per square foot. That's a pretty substantial decrease in time. Panel connections. We're actually not doing, since we're not going to do an asphalt overlay, we're not going to do this connection plate. We actually countersink the bolts into the SPS down into and attach it to the stringer. That way, and actually we come back, which I'll discuss here in a little bit, where the riding surface will want to be epoxy system, epoxy aggregate system. They can accommodate the rails, any type of rail we want to put on there, they can accommodate it, or it can accommodate it. And in this case, this bridge, we're using the F1, the T1F, which is a fairly light rail. It's a fairly light, non-sacrificial rail. Expansion joints. We can use pretty much accommodate any expansion joint we have in our inventory with little to no modification. Drains. We can still cut drains into it, and we don't have to do much modification to the rails to accommodate these drains. Now here's what probably a lot of you are worried about or concerned about is the wearing surface. The wearing surface is basically, we already have it in our standards as a multi-layer polymer overlay, TxDOT specification 439, bridge deck overlays. Basically, it's an epoxy with an aggregate overlay, which is generally about 3/8 of an inch thick. And a replacement cycle is about 5 to 10 years. I don't know how that correlates to asphalt. If somebody would enlighten me, that would be great. And that also depends on the product. Ease of and that's also based off of Texas climate, which is pretty detrimental to a lot of things that are chemically based. Ease of application, you actually have a fairly large temperature range which you can apply the epoxy and the aggregate, 32 to 104 degrees Fahrenheit. Clean surface, of course, according to the specifications of the product. You need to apply a primer, and then apply a resin with the pot life to 15 to 20 minutes. And then you broadcast your aggregate and apply your sealant. This is your panel thickness to depth ratio to span length. If your stringers are for the 1 3/4, 57 feet between girders / stringers, and so on and so forth. Based off the AASHTO LRFD table 2.5263-1. Grading. Grading, we just do it off the stringers. We're actually not going to use the existing stringers. We're going to replace it with new stringers, and then those stringers will be adjusted to give the deck the proper elevation. Distributors, you might be asking, well, how available is this in the U.S.? There's one manufacturer right now, or one distributor right now in the U.S. It's located in Ohio, but hopefully the proprietary Intelligent Engineering, which owns and developed this product, says they should have another one by the end of this year and possibly another one after that sometime mid-next year. Due to costs, we're not recommending this for off-system bridges, definitely on-system and definitely high or a lot of traffic. We'll use it as an alternative. Contractor make that determination. Luckily, the benefit to it is no gusset plate strengthening, hopefully not, or replacement. Very little to no rivet bolt replacement. And it'll actually shorten the construction sequence, and if the availability of ready mix is not that great, this would be a good alternative. Any questions?
Yeah, at the perimeter of the plate,
Mm-hmm.
and also where you cut holes in it, it looked like there was a 4-inch wide by 1-inch thick bar. Is that installed in the field, or does that have to be done in the shop before they inject the polymer?
Go back to it so everybody can see it. Where you at?
There was a picture of this plan.
Yeah, it should have been right. Oh, there's a good, there's one. Yeah, there's a section there. Now that, what you're seeing there, that bar, he's asking about this bar right here, or this steel piece. It's installed in the shop. Everything's done in the shop. The only thing that's not done in the shop would be, of course, the connection to the stringer.
Okay, so even the drain holes have to be shop fabricated?
Yep, even the drain holes. Everything's done in shop because it has to be, that polyurethane has to be injected. And as soon as it's injected, it's totally sealed. So that's how they're doing that. Correct. Everything's done. Everything that you can possibly do in the shop is done in the shop. I mean, I'm sure they can make adjustments as needed. She was asking about the rail, if the rail attachments are done in the shop or if they're done in field.
It looks like your field welding is only in that area where there's polymers away.
Right. And I actually asked them about that too, the actually developers, Intelligent Engineering. Yes, but since we had to talk about the fire rating, because I was like, it's a polyurethane core. That polyurethane core starts getting hot, it's going to melt, it's going to degrade, and they go, since it's hermetically sealed and it's not exposed to the environment, it actually will just re-solidify, and there little to no chemical change, and you won't destroy that bond between the two plates after it's set, after it's solidified. Any good questions?
Any testing has been done to that theory?
Not that I know of. I've asked them, but they go, no. That was a good question. I mean, that was something that's been brought up, is fire rating, and they don't seem to have an issue with it. But fire is on top. Unless it's something below, the fire shouldn't really affect it that much because the heat's going to rise. But if it was something below, then that's a different story.